Okay, hello everybody. Welcome to the Worm is for Grazers presentation with the Tor Valley and Little Dart Facilitation Fund. My name's Jack Wolfenden. I'm one of the co-facilitators on this group, and the focus of this group is to share experiences, training and cooperation and joint working between landowners in the catchment. And you can reach me on the following email, jack.wolfenden@devon.gov.uk. Today we're joined by Emily Dawson from Torch Vets, who's going to do a presentation on Worm is for Grazers. And toward the end of the presentation, there'll be an opportunity for questions and answers. And as I mentioned at the beginning, there'll be a recording available for people that like to watch it in their own time. So without further ado, I'm going to stop sharing my screen and I'm going to invite Emily to start her presentation.
Right. Hope the tech gods are with us. So, can I just check? Can you guys see my presentation? Okay. Hello.
Yeah, all good. Okay,
yeah.
Thank you.
Perfect. So thanks, Jack, for the introduction. My name's Emily. I'm a clinical vet with Torch Vets. I deal with our farm animals, predominantly beef and sheep. So I've been asked to come to chat to you guys today about parasite control and wormers and how that sort of fits in to managing our lands. So move forward. Lovely. So gutworms in our livestock, beef and sheep wise, follow a very similar life cycle in the environment and within the host. So just a little bit of a recap over how that works for us. So our grazing animals will graze pasture and pick up eggs off the pasture. Those eggs will develop into our disease-causing or potentially problem-causing adult worms and egg-laying worms within the animal. They go through a few stages throughout that. So eggs are dropped in dung and they develop in what we call larval stages, and these larval stages on the pasture can move around. So they will actually migrate up grasses and things like that in a bid to be eaten by the next sheep or cow or horse that comes along. That whole cycle varies in how long it will take depending on a few different factors, including weather patterns, the actual species of worm, and what's going on in terms of livestock on the pasture. So this is a general overview of the sheep life cycle, and as you'll see here, the cattle life cycle is pretty similar in its makeup. So why do we worry about worms in our livestock? Well, worms have developed themselves to be able to live in the gut and take nutrients from the animal. In the process of doing that, they can also cause damage to that animal's gut lining through their feeding patterns and things like that. So a combination of the worms stealing some nutrients and the damage to the gut stopping the animal absorbing nutrients means that we can see livestock that have reduced daily live weight gains. This reduces their feed efficiency, and that means that we have an increased time to slaughter for animals that will go to slaughter, or in other words, a slower growth rate. Add to that fact that if animals get a big enough burden and enough damage to their intestines, then that can lead to that animal being really sick and ultimately could lead to death. All of the above also leads to increased costs for our farming enterprises, which, as I'm sure everyone can appreciate, if we can make things more efficient, then we have more free money to improve things elsewhere. So just a little diagram on the right here, just to demonstrate that a lamb putting on 100 grams of weight per day will take 14 weeks to finish, and they'll take 120 kilograms of dry matter in order to do that. Whereas our lamb growing better, so presumably with, or possibly with less worms or and less challenge, are going to grow, if that lamb's growing at 300 grams per day, that's going to take 5 weeks to reach finishing weight and take 65 kilos of dry matter. So half the forage, whether that be preserved forage or grazed forage, to get to finishing weight. So it can be quite a drastic difference, and that can affect then how we utilise the rest of our land over that period as well. So historically, the answer to this problem has been wormers, whether that's in cattle or sheep or even horses, for those of you that might graze horses as well. And we term these anthelmintic treatments. And we have 3 historic wormer groups available to us: our whites, our yellow and our clear drenchers. And that's predominantly what we have available for our cattle. In the sheep sector, in slightly more recently, we've had 2 new groups of wormer appear, our orange and our purple. So for anyone grazing sheep, that would be our Zolvix or our StarTech products. And we've tried to keep these a little bit separate. Unfortunately, they're not available for cattle at the moment either. So what's the problem with that? Why are we looking to reduce the use of these products? I'm sure you know, if you've been out and about or spoken to vets, there's a big push to reduce our reliance on anthelmintic treatments, and this is for a few reasons. One, from the very veterinary aspect, is drug resistance. There's increasing resistance to these products, and we'll go on to talk a little bit more in depth about that in a second. The second really hot topic at the moment, obviously, is the environment and our ecological impact through farming on our surroundings. And then the third one that plays into that is also cost. Any treatment we use has a cost associated with it, both in terms of buying product, but also a much wider cost in terms of, like we talked about, our growth rates in animals, our welfare in animals as well. And cost will also play back into the environment and how our land works for us. And then, so once we've had a little look a bit more in depth about the whys, we'll talk about how we can go on to reduce our reliance on these products. So a little bit about wormer resistance. So when we talk about resistance, we're talking about a scenario where a treatment that we use provides a suboptimal response. So provides less than 95% reduction in the worm egg count. What that means is we're not killing all the worms in the gut of the animal when we use a treatment. Anthelmintic resistance is heritable by the parasite. So as they breed, they will pass these traits on. And it's that the genetics give them the ability to tolerate what we class as a normally effective dose of anthelmintic. So some worms, even without these genes, if they don't get a big enough dose, would survive. But these are worms that, all else being correct and at the right dose, are still surviving that treatment. And like I said, that ability is passed on to the parasite's offspring. So the more resistant worms we create in the gut, the more resistant eggs hit the pasture. And that would gradually change the status of the worms on our grazing. And the end outcome of this is that the treatments that we use in our animals, they stop being what clinically effective. So to begin with, we might not notice too much in that we reduce burden significantly enough that the animal starts thriving again, you know, is putting on weight normally. But as that proportion of resistant worms increases, we're clearing out less and less of those worms from the gut with the treatment that we're using. And just as a little bit of evidence to back me up with that, this graph here is from a study that was done with some of our farmers here in the southwest. And they were looking at these farms through 2013 and 2016. So a little bit of historical, but these things take quite a while to get published sometimes. And what this graph is showing is the results of fecal egg count reduction tests. So this is looking for how effective a wormer has been on farm, and this is looking at 13 different farms over the 2 years. And what we're showing here is the amount of resistance to each class of wormer. So our BZs would be our white wormers, and as you can see on this graph, all of the farms that we sampled and were tested, 100% of them had resistance to the white wormers on farm. Our yellow wormers are levamisols on the second bar. 7 out of 12 of these on the first year showed some resistance, but by 2016 that had increased. Our ivermectins or our clear drenchers, similar sort of story, a decent proportion, 9 out of 13 in 2013 were resistant. By the time we checked them again in 2016, all of the farms we checked had some ivermectin resistance. And moxidectin is a subcategory of our clear drenchers, which has come into the limelight a little bit more recently. And so this would be for the sheep and cattle are Cydectin drenchers, which has some persistent activity, so has become quite popular for providing some persistent cover to animals. But as you can see, there's also some resistance to these building on farms as well. And interestingly, when you look at take each farm and add up how many groups are resistant, in 2013, a large proportion of them, 2/3 of the farms, had resistance to 2 groups. By the time we get to 2016, that's become almost 3/4 of the farms having 3 different groups that they're resistant to on farm, and some of those also had moxidectin resistance. So that's the vast majority of our available wormers that are seeing a large proportion of resistance on farm. And what this essentially means is that in the long run, we're going to get to the point where we don't have any wormers that will do a 100% effective job for us. And then if we kept going at a significant rate, we'd end up with no chemical products that could help us in the control of gutworms in our livestock. So that's our sort of resistance problem. We want to reduce what we're using to reduce the pressure on these chemicals, to reduce the buildup of resistance within the worm populations that we have. Our next little sort of topic was our ecology, and the big factor at the moment, or the big news bulletin is about our dung beetles. So we'll talk in this instance about dung beetles and why we're concerned about them. But these factors will also affect other invertebrates on the land, even our earthworms and things like that. It just is that dung beetles have been probably the most studied in this scenario so far, but there'll be building evidence of effects of our wormers on other invertebrates and other parts of the ecosystem. So dung beetles are really important in terms of maintaining our grazing land, basically. So they're little engineers, and there's a few different types of species, and they essentially fall into 3 categories. The 2 that are most important in the UK are the tunnelers, and they're the ones that create these puncture holes in the soil architecture underneath dung pats, and are the ones that live in the dung pat are our spreaders. They spread the dung around and break it all down, remove it from the pat on the land. And they're really, really good all round for our environment. So they improve the soil structure by aerating it. They're little fertilizers of their own. They're taking a product that's landed as a byproduct the cattle and the sheep, and they bury that into the soil where that nutrients can be retaken up by the forage and the plant structures on there. They help aerate and reduce compaction of the soil. There's a degree of greenhouse gas regulation going on, so whilst that dung pat sat on top of pasture, it's giving off methane. So the quicker that's sort of broken down, spread out, taken into the soil, the less methane's released. So obviously another plus for our environment. It reduces the amount of dung sat on the pasture for as long, so you don't get those horrible yellow spots that stop the grass growing and things like that. They also contribute to pest control, and this becomes a little bit relevant when we think about how we can encourage these guys onto our land and encourage them to help us with our land, because they eat some of the fly larvae that gets laid in the dung pats, and then in turn reducing the number of flies in the environment that go on to hatch and annoy us, cattle, anyone in the vicinity really. They can also, through similar mechanisms, help our GI parasite control, a combination of factors, but mostly because the parasites need to move on to vegetation from the dung pats, and they need to go through a few different larval stages, and the dung beetles remove the pat for them to live in firstly, and also create a drier environment, which means the larvae can't mature as easily, and it reduces that contamination, that it reduces the number of gutworm larvae that are available to be grazed and taken up by the livestock. They also, by altering the soil, can affect drainage to an extent as well, and water retention, and they're also in themselves then become part of that ecological life cycle. They become food for some farmland birds and small mammals, and actually there's a number of bats that are quite reliant on certain dung beetle species, so they then go and add into that wider biodiversity for us as well. And the reason these little guys are a hot topic in terms of worming and parasite control is they're actually really adversely affected by a lot of the drugs that we will use to chemically control worms. So our big hitters are our ivermectins, but they're also affected by our triclobendazoles, so these are our fluke drenchers, and to a slightly lesser extent our moxidectin, so our cydectin that we talked about. And I said fly products also relevant, so these are our synthetic pyrethroids, which are our fly porons and fly preventatives. These are also fairly toxic to the dung beetles. There are some chemicals that are less likely to affect dung beetles, but I would caveat that with saying that whilst some, for instance, our white drenchers are not quite as toxic to our dung beetles, they can be quite toxic to if they get into watercourses and to aquatic life. So whilst these are the most important for dung beetles, I think we need to bear this in mind, that there are a lot of other species out there that will be affected by the other products. So anything we can reduce, anything we can do to reduce chemical control is going to help that biodiversity and ecological impact that we have. So what can we do to reduce these impacts? What can we do to help the dung beetles, to help the environment and our pockets, whilst keeping our animals fit and healthy and productive for us? So a lot of this is going to boil down to some principles that have been set out for sustainable control, and there's two big bodies, one for the sheep and one for the cattle, that have put a lot through different industry stakeholders into research and producing guidance on this sort of thing. So that's SCOPS for our sheep, which is our sustainable control of parasites in sheep. and cows, which is the cattle version of this organisation. And the first thing that they suggest as their first guiding principle is reducing the use. And we can do this with a few different strategies. Firstly, testing. So testing for a need to treat. If we can get away with not treating, then that's obviously a really easy way to reduce what we're using. And we can also use some forecasts, parasite forecasts, which I'll talk about a little bit later. And then the last part in this preventing what we use is we term avoidance. So can we avoid picking up these parasites in the first place, or reducing the number of parasites that are going to be picked up to avoid having to treat. And then the second part of their recommendations revolve around when we do have to treat, making sure that we treat in a really effective manner. So choosing the right animals, the right products, and getting our dosing and timing correct, so that any product we do use is having maximal impact with minimal for the animal and for the worm control, but with minimal impact on the environment and resistance building in those products. We cover this, or I like to sort of cover this whole principle as we're trying to use as little as possible, but as much as necessary, and it's finding this nice balance that's important. So a little bit on testing. So our mainstay for testing for parasites is our fecal egg counting. So this involves taking dung samples from a proportion of a group, and they are run we basically float the eggs in the dung and we count them under the microscope. And we can work out from those how many eggs per gram of faeces we've got. Now in sheep, that's a really good indication of the number of adult worms in the gut of a sheep, or if we use mob samples for a group, the average number in that group of animals. It's not quite so linear in cattle, as in it's not quite as clear cut that 100 eggs per gram means X number of adult worms in the gut, but it's still really useful for knowing which animals are carrying gut worms, and also can tell us a lot about how those eggs are affecting the pasture, how many eggs might be producing a problem for later down the line. And we can also use them in our horses as well, to guide whether they're carrying a burden or not. And lastly, they're really useful for checking the efficiency of the wormer that we've used. So we talked about there being resistance. One of the most important things to do in terms of future-proofing your farm, in terms of wormer resistance, is checking what the status on your farm is. So every time we use a worming product, we would encourage that you test before worming, and then definitely after we've used the wormer. So generally it's 2 weeks after, unless you've used a yellow drench, in which case it's just the 1 week after treatment. And what we're looking for is that egg count, that number of eggs per gram, has dropped sufficiently. So ideally we want to see no eggs at that point after worming, but we want to see that it's been at least 95% effective for that product. And if it's not, then it starts to build a picture on that farm or on that patch of land of what the situation is, and we can start to then put things in place to combat that. Alongside the testing, we can also use some of the parasite forecasts to sort of help know if we need a certain dose, when we might need it, to time it right so that we're not having to use repeat treatments to cover the same problem. So on the left here is the map that's produced by SCOPS of the nematodirus risk in the UK. And what they do is they use weather stations to predict when nematodirus is going to be hatching on the ground. So nematodirus is a bit of an odd worm. It overwinters on the pasture and it waits for a perfect set of weather patterns to emerge all at once, which is quite unusual for the gutworms. That mass hatch, the fact that all the larvae sat on the pasture will hatch at the same time, can be really detrimental to young lambs. And so what SCOPs do is they monitor the weather stations for those weather patterns, and they give a risk prediction for that area. So all the little dots on this map are the weather stations that they're watching, and the colour of the dots is the risk in that area. So red being our high risk, black being our very high risk. Any susceptible lambs at that point are at high risk of nematovirus. And similarly, we can use similar weather patterns to predict our fluke. So our cows tend to have a nice little fluke indicator, and they watch weather patterns and also reports of disease to give farmers an idea of when fluke might be becoming a problem, when to time testing or potentially treatment. Fluke's getting a little bit harder the more we our weather patterns change. It used to be very it used to follow the calendar beautifully, and we'd have a high risk period for the sheep in the autumn, followed by a higher risk period of chronic disease in the cattle over the winter, sort of December, January time. And we're finding with warmer, wetter, more unpredictable climate that that's becoming a little bit harder to predict. So using testing data within that can help us to get that a little bit more accurate. The next little thing we can have a think about is how we manage our pastures. And the first thing I've popped in here is about some anthelmintic foragers. So these are plants that provide some worm control. Now, there's a lot of research going into these pastures at the moment. It's still not fully understood how they work, but sort of plants we're talking about here are chicory, bird's foot trefoil. Anything that contains tannins seems to be the ones that are providing us with some useful anti-worm properties. There's not 100% agreement on how they work, and the likelihood is they work through a few different mechanisms. But the theory is that they reduce hatching of the worm eggs on the pasture, and they also seem to, or chicory particularly seems to reduce the motility of the larvae. So when the eggs hatch into larvae on the pasture, they then like to crawl their way up the herbage to a point where the livestock are likely to graze them and ingest them. And they don't seem to be able to do that very well up the likes of chicory, thereby reducing the amount that are taken in by the livestock. There's some really good evidence of this in our lambs, and there's some good proof that fecal egg counts or worm egg counts are reduced in lambs grazing these pastures of chicory or mixed pastures. There's less evidence in adult animals, and there's not very much reported at the moment in cattle. Most of what we've got is information-wise is in sheep at the moment. Another big plus for them, though, is they're also a really good source of protein. So for any growing animal that has a high protein demand, they provide that really quite nicely. And if the animal's growing well, it has a stronger immunity. It's generally healthier, then it can actually withstand a lot more in terms of worm challenge than an animal that's struggling nutritionally. So there's probably also an element of that in there as well. And another little plus side for these plants is they tend to have quite extensive root systems and quite complicated root systems, and they can also add to aeration and drainage in the soil and provide improvements in soil structure and things like that. Now, they sound like a bit of a wonder drug, and I don't doubt they have a place in farming and in improving how we manage our land. However, they're not always the easiest things to seed and to grow, and they won't grow everywhere. I am I'm not really particularly green-fingered, I'll have to admit. That's the sort of thing that probably needs someone with a little bit more knowledge than me. But it's certainly worth looking into whether we can mix some of these forages into our grazing to increase that biodiversity, help our soils, and also hopefully increase or reduce our worm problem on pastures. And the other thing we can do with our pastures, so obviously it's important what the animal's eating, and the quality of that plays a big factor. But we can also work into our systems some risk assessment of those pastures. So we want to know how risky is the pasture, how likely is that pasture to have a large burden of worm eggs or an egg larvae on it, and how susceptible are the stock that we want to put on that. So on that basis, when we're thinking about our cattle, our most susceptible stock are autumn-born weaned calves grazing for the first time, or our second season grazers, especially if they haven't had a particularly long grazing season or a particularly risky grazing season the year before. And our high risk pastures would be pasture grazed by cattle in the previous 12 months. So, if cattle have been on that pasture, the likelihood is there are eggs on that pasture. So they would be more high risk than something that hadn't been grazed. And for our sheep, our most susceptible stock would be our lambs from about 6 weeks of age, which is when they generally start grazing enough to be potentially taking worm eggs and larvae into their system. Ewe lambs as well, up to a year old. And the reason we've got these sort of age groups on there, most animals will build immunity to gutworms over time, and they'll become, so for an adult cow or an adult ewe, they will have an inherent immunity and be able to, for the most part, ward off any issue caused by the gutworms. But these younger animals are the ones that haven't yet built any immunity, so they're the ones that are going to get sick, that are going to suffer low growth rates potentially up to around a year, 18 months, until they start getting that immunity. And for the sheep, our high risk pastures, anything grazed by ewes and lambs in the previous year, or if they're grazed by store ewe lambs that the previous autumn winter, so before those ewe lambs have started to gain enough immunity to be less risk, basically. So how can we reduce some of those risks? So we talked about cattle pastures being risky if they've been grazed within that last year. Resting paddocks can help it to break the cycle, and over time, if eggs and larvae aren't picked up, they will gradually die off. And if there's no animal, no cow or sheep to perpetuate the cycle, then that will slowly reduce the burden on that pasture. Silage aftermaths are also lower risk, again due to the fact that we're taking the part of the sward where the active larvae are likely to be sat, and also that is likely to have been rested for a period in order to grow, to be silaged, and that sort of thing. So silage aftermaths are generally considered fairly low risk. Grazing with another species. So all these worms are fairly species specific, with fluke being the big exception, really. Fluke will infect cattle and sheep, but most of the cattle worms won't infect sheep, and the sheep worms won't infect cattle. So if we can alternate what species are grazing, and that would apply to horses as well, and if we can alternate species, then we can use them almost as hoovers to clear the ground of eggs and larvae on the pasture that might affect the next species to come along. New lays obviously would provide a perfectly clean pasture. And then we've got here our leader-follower system. So what I mean by that is leading onto new pasture with the most at-risk stock, so those young stock, those young lambs, those young calves, being allowed access to the safer pastures first, and then being followed by a and older animals. So whether that be you know, barren cows, for instance, or barren ewes or older ewes, following on behind as a bit of a hoover to eat up those larvae, eat up those eggs, and use their immunity to clean that pasture up. And maintaining sward heights, this is quite important for the sheep to avoid grazing them too low. We talked about the larvae liking to migrate, but the shorter the sward, the more larvae are going to have got further up that herbage, and leads to a bit of a higher risk that the animals will graze and eat those eggs and larvae. What we can do with some of these things is start to make a map of the farm and of the land that we have, and categorize that land into different risks. So we can, if we each year we document where we put different kinds of stock, and so this one's for sheep that I've used as an example. You know, if ewes and lambs have been on some fields earlier in the year, then that's high risk to be thinking about putting any young lambs back onto. Conversely, you know, if we've got a new lay on a field, you know, it was arable last year, so it hasn't seen livestock either, then that's a nice low risk pasture. That's somewhere that we could put our young lambs onto, that we know is not going to have too much of a worm burden on it. And we can start to then plan how we graze different fields. One, to reduce risk to our animals and therefore reduce the risk of having to use wormers. But we can also plan in terms of what stock we can use to clean up fields. So, and again, long term, that's going to reduce our reliance on chemical control of these things. If we can, for instance, graze some cattle over a high risk field for the ewes and lambs, we reduce the egg burden. If we then have to put sheep back onto that pasture, then we're hopefully going to slow down that upcycling of eggs and larvae on the pasture. A little note on genetics here. So the immune response we talked about in adult animals, there is a genetic component to that, although only part of that variation is genetic. There are a few other factors that are involved, some of which we know about, some of which are still sort of being looked into. In the sheep side of things, there are estimated breeding values available for some breeds. So the Clin and the Landowners have started looking at sheep that genetically seem to be predisposed to having low fecal egg counts. So that would suggest an increased immunity for those animals. The only slight problem with thinking about this on a genetic level, well, one would be that at the moment its data suggests only about somewhere between 10 and 20% of the immune response is down to genetics. So we might not always see complete control through genetics alone. And the other side of that is that the immune response creates a need for energy. So any immune response the animal mounts requires energy, and actually there's a bit of data that suggests that these animals with good genetics for low fecal egg counts actually possibly don't grow as well or as fast, because they're putting energy into being immune rather than energy into growing. And so this has brought this question of resilience versus resistance. Whilst low egg counts are great in terms of our pasture and keeping not secreting as many eggs back onto pasture, if they're taking some of the productivity of the animals away, certainly on a commercial level, that's suboptimal. So the new area of research is on this term resilience. So animals that seem to be able to grow despite a slightly higher egg count, and that's still very much a work in progress. And certainly in New Zealand, that seems to be quite at the forefront of some of their breeding programs at the moment, and seeing how they can create an animal that is has some resistance but is resilient to these worm burdens too. So that's a little bit of a watch this space, but genetics definitely do play into to some of these things. So this is our pasture management, our genetics, and our testing is all about avoiding our treatments and trying to reduce how many treatments we're using where possible. And the other side of making sure we've got good control is about when we do need to use these products, using them right. So on the SCOPS website, there's some brilliant resources about checking your dosing practices. And just to go through these a little bit for you guys. So right animal, what we're alluding to here is the fact that we're testing, that we know that that animal definitely needs treating, that a treatment is required before that we're using any product unnecessarily. And that might be testing through fecal egg counts. There is also some stockmanship involved too. So those animals that aren't gaining weight, that have dirty backsides, things like that, they're the animals that are going to need treating. Choosing the right product, and again our testing comes back into this a little bit, knowing what resistance patterns we have, what will work, what won't work, and possibly even time of year for some of our products as well, and making sure we've got the right dose for the animal. So dosing to the right rate for that group in front of us. So we always suggest dosing to the heaviest in the group. That avoids us underdosing. Any animals underdosing of wormers will drive resistance quicker. It drives those genetics in the worms that are predisposed to surviving that treatment. And then making sure guns are calibrated, injectors are calibrated, and employing good technique when handling and restraining animals to dose them. So how does this all play in? How what are the next steps for going and implementing some of these things that I've thrown at you today? So in my mind, active health planning alongside your vet is the best way to put some of these things into action. Creating yourself a plan that's specific to your farm. So thinking back to the map of the risks on each pasture, if you can map your farm and know what's high risk, what's low risk, then you can much easier plan where to graze stock, for instance. And the vet, your vet can help feed into these plans in terms of looking at some of these forecastings and what time of year certain fields might be more or less risky. And they can feed into your treatment plans as well. I also think something to make just a bit of a note of is record keeping. It's, in my mind, more and more important to try and keep records of what you do, and beyond just your standard medicine records of who's been treated, but trying to keep those records on your pasture map as well. And that way you can track your grazing easier, but you can track your progress too. Is nothing nicer than implementing a plan and seeing, for instance, the egg counts on a certain pocket of land reducing over time because you've grazed them more efficiently and more effectively. So yeah, really encourage you to keep records as you go along, just to track your progress. I've popped the bug safari down here, so I don't know if anyone here has been to any of the dung beetle events. There's been a couple in the area over the last couple of years, but there are events out there. Certainly at Torch we are hoping to hold another one this summer, where you can learn to go out and check your dung pats and check for dung beetles and figure out how, do you have any dung beetles for starters, and how can you start to think about how you can encourage the dung beetles and other invertebrates back onto the farm, so that they can help us maintain those pastures and reduce the egg counts for us in a essentially free free way. And the last little note before I just open up to some questions, the Animal Health and Welfare Pathway is a government funding programme for cattle and sheep farmers, and there's a packet of money that you can sign up to be eligible for. There's some specific testing that has to be carried out within that. So for the sheep at the moment, that's carrying out some worm egg count testing and some resistance screening for one of the wormer groups. And for cattle, that's BVD testing at the moment. But then there's a pocket of money available to use around that. And I think, you know, if you're interested in getting a bit of a better grip on grazing and a plan, then that's something that definitely could be used alongside with your vet to put some of these farm-specific plans in place and have a little bit of a deeper dig into it on your farm. So that is just a flag to say that is available, and I can provide links to more information on that one should anyone want it. I've added some of the resources on here. Like I said, the two big ones for me, the SCOPS and the COWS websites, have a whole host of information aimed at farmers and livestock keepers on ways to reduce use and to ensure that what we use in terms of wormers is as effective as possible. And this one here, the dung beetles for farmers, is a really good resource on all things dung beetles. We've had some great speakers, including Sally Ann Spence before, who they're very passionate about their bugs, and it's very infectious, and it's a good place to start for any more information on that side of things as well. So hopefully that's given you a little bit of an overview on wormers and where we might start to have an impact on reducing our use and our effect on the land around us. And I guess I've finished now and see if I can open up to any questions if anyone's got anything I haven't managed to answer as I've gone through. I come out. Yes, lovely.
Great stuff. I can still see your screen.
Okay, hang on.
But thank you so much, Emily. That was fantastic and some really really useful information there. Could I open up invitations for any questions from the group? Yes, Jeremy.
Yeah, I think I might be with you now. Thank you. Thanks very much, Jack. And Emily, that's really interesting. Know a bit about it, but it's good to know a lot more. We've got about 80 years, been doing it for a long time. But over the last few years, we've taken advice. I can't remember exactly where the advice came from, but changing types of wormer, but doing quite a lot of egg counts and always testing before we use the drench. So when we've got a wormy looking lamb scarring, and we've only been treating the ones that are scarring or not doing very well, so too light for what they should be. And we've done that for about 3 years, and it does seem to be quite successful. I have to say that a couple of times we've had an outbreak, usually in the spring, you know, a mass egg hatch or whatever. And I think it was last year we had to go back to a white drench to deal with that problem, but that did deal with it. What we're not doing is testing post treatments, which I think perhaps we should be doing just to try and understand with how effective they are. But it does seem to be working, that regime of only treating the animals that look like they need treating, and rarely, well, we use perhaps on lambing. We might treat before we let out, perhaps. Not sure if that's right either, really. Thank you very much anyway.
No problem. I've just picked one little bit out of that one, and it's the treating use. I think by and large it sounds like you're very much doing a lot of what, you know, we would suggest, and only treating those animals that are symptomatic means that even when we have to use a dose of wormer, that not every bit of dung that goes back out onto that pasture then contains the worming, the chemical products. So that's always going to help our biodiversity as well. So that's brilliant. Worming use around lambing is a bit of a double-edged sword. So the reason that it's in the literature and that it's been encouraged is because around the period of lambing, that ewes immunity drops, and that's due to the fact that she's got her mind on so many other things: growing lambs, lambing them down, coming into milk. Her energy's being spent elsewhere, and what that can do is just increase the number of worms that are sitting alive in that ewe's guts, and that will increase the number of eggs put out onto the pasture. In itself, not a problem for our ewes, but what that does do is increase the number of eggs that are then available for the lambs to graze. So there's a real balance to be had with this one. Evidence would show that if a ewe is relatively young, fit and healthy, carrying a single or a twin and is in good body condition, that increase is fairly minimal, and that actually we could probably get away with not dosing those animals. Conversely, the animals that will have a rise in worm egg count will be those animals that maybe aren't carrying as good a condition for whatever reason. They're older ewes where their immunity is starting to fall down their list of priorities, as it were, or that have been sick in another way. So a chronically lame ewe, for instance, or that's had a bout of metabolic disease around lambing. So we can start to target some of those treatments to really help reduce contamination of the pasture whilst reducing how much overall wormer that we're using as well. So hopefully that's a little bit of snippet for you.
Mute again. Yeah, thank you for the advice. That's really good. We'll try and do that. It makes sense. The wormers are expensive, so the less we use, the better.
Exactly.
For the financial reason, if that's not an incentive, what is? So,
exactly.
As well as all the other things. So, thank you very much. That's great. Thank you.
Sorry, Mike.
Thanks, Jeremy. Would you like to answer a question? Ask a question, Mike?
Yeah, thanks. So we're in a very similar place to Jeremy, really. So relatively low density of sheep on the land, and we treat literally dirty backsides, and we've got to a stage now where usage has dropped dramatically, and really with the ewes, very rarely treating the ewes, but with the lambs more frequent. I had two questions really. One was, is there any proven value in keeping the stock indoors for a number of hours after treating them to reduce the environmental impact back onto the pastures? That's the first question. And then secondly, are there any non-chemical treatments that work? I previously have treated them with garlic powder, and that seems to have an interesting impact on them, and I wonder whether there's any science behind it.
Yeah, so in terms of residues and going out onto the pasture, the ivermectins especially, which seems to be what most data's on, will be secreted for a fair number of days to weeks through the dung. So I think the impact of keeping them in for a few hours is fairly minimal. If we're going to have that impact, if you like, we're talking, you know, a week plus to keep them indoors, which generally speaking isn't particularly feasible. Some people will use a bit of a sacrificial field, so a portion of land where they might be able to stay for short periods of time, where if they've been dosed, that's where they go for a bit, and then they move on to pastures where thereby keeping some of the chemical products off the vast majority of pasture. Practically, again, depending on grazing, how grazing's growing at that particular time can be a challenge. So I think anything to just reduce the amount is probably going to be more effective long term. And the question about non-chemical use, garlic powder, there is some evidence out there. It's one of those, again, where they're not entirely sure of the mechanisms necessarily, but it does seem to have an impact. I do know there are some dairy farms that will use for fly control as well, for instance. The trouble with things like the garlic powder is they do taint things, so anything producing milk and potentially anything producing meat, there's a risk there of tainting the product. And from what I've read in the past about it, the levels to produce an effect seem to be much higher than the levels that don't produce any taint. There are products in other countries out there looking at using different fungi that are passed through the feces and essentially outcompete the eggs and the larvae again and stop them being able to migrate off the pat and therefore into the herbage to be ingested by the animal. There's nothing currently licensed in this country, but it's going to be quite an interesting area to keep an eye on to see if any of those products start to come to the UK market. The evidence base for them is low, in that most of what's been done has been by the companies that are trying to market them. And as a vet, we're always a little sceptical until we have some independent evidence. But it's certainly an area that I think, you know, it is promising. And if we can prove that the evidence is there that it reduces the egg count, the bits that we need are that it's not going to impact the wider environment, the other species that are relying on dung pats, for, you know, like our dung beetles and our earthworms and things like that. And if we can find that, then that might well be a very good option for non-chemical control. So it's a bit of a watch this space with that one, I think.
Great, thanks. That was a really useful presentation. Thanks a lot.
No problem.
Hello, can I ask a question? How long does wormer be detrimental for the environment? Would it be the withdrawal period for the animal? Because using this one, mold, it's got 143-day withdrawal, which is rather scary, I think, because it's a long time. Now, if I use that when they come in a couple of weeks after housing, that's not too bad, because they'll be in all through the winter and they won't be out grazing really until the withdrawal period. But that's all I use really once a year. So I'm just wondering, then it's safer during the summer when they're pooping out on the pasture. Hopefully it won't be so environmentally damaging. Am I correct in that thinking?
Yeah, now I'm not sure how much evidence there is as to just how long. We know the ivermectins are quite slow to break down, and moxidectin would fall into that group. In the right conditions, so if it's piled in a muck heap, for instance, and it gets warm enough, then it can be broken down in as little as a week. But without those sorts of temperatures, it will live in the dung pats for a long period of time. Like you said, once the animal's cleared it out the system, then it shouldn't be being produced then in the dung. So on the dung, on the pasture, it could probably very easily be there for months potentially. Once it's cleared through the animal, then and it's not being secreted, then it should be fairly safe. So the trouble is we don't have an exact time frame for that. And again, it's work that's, you know, as these things are becoming more and more vital for farming and for sustainability, then hopefully we'll get more information. I'd say if they're housed and they've gone past the withhold, then the likelihood that they're passing anything in their feces at that point is small. So you're right, absolutely right, that'd be safest. How long after they're dosed are they secreting in their feces is one that's not 100% sure, but likelihood is at least a few weeks to a certain degree.
140 just for meat.
Oh, thank you. We have found dung beetles in the dung once they're grazing out a little later on, and that's having dosed them with this when they came into housing. So hopefully in the summertime that they're not, it's not going to be too detrimental anyway. Yeah. Yeah,
hopefully. You know, the dung beetles, it's really good you've got them for starters. That's always a really positive thing to find. You can find dung beetles on dung pats that have been treated with ivermectins. Depending on the dose in the dung, it will sometimes kill them outright, but more often reproducing. So keep an eye on your dung beetles, you know, that they're still there. You know, do yourself a little bug safari every now and again just to check that they're coming back and that they're breeding. And and you know, that, to me, it's a really positive sign that they are there, and if you can see them year on year, and wow.
Great. Okay. The other thing is, for egg counts, presumably sampling from different groups is the best thing. I mean, rather than like a whole herd, right? I've got different groups now within, so I thought now would be a good time to do weaned calves, cows, and yearlings, for instance, right, in different groups.
Yeah, absolutely, and always group on age. So never group an adult animal with a young animal, and on grazing patterns. So if you've got sort of a weaned group over here grazing one particular pasture, class them as one group. You know, if you've got 3 sets of lambs on 3 different fields, that's 3 different groups to test, because they'll have all been exposed differently. But yeah, any sort of management group essentially, but making sure.
Is it worth doing egg counts now that they're inside as well during the winter time?
Yes, I think it probably would be, because what it tells us is what they've been exposed to in the grazing season, as long as they haven't been treated since they've come in. If they've been treated since, then it becomes less relevant. But that adds 2 things. One, do they need treating? Is there a worm herd in there to treat whilst they're housed? And if there is, we can do that appropriately. But it also gives us some information on the ground that they were grazing before they came in. So, if they're producing 200, 300 eggs per gram, then the likelihood is they were doing that when they're out on the last pocket of land, and we know that therefore that there's going to be some egg contamination on that land, and we can have a think about how it's best to graze that following season. So it starts to build up this picture of our whole farm map, really.
And how about fluke? Can you test for fluke?
Yes, absolutely can test for fluke. It's not quite as reliable, and there are some challenges, but we can use dung to test for eggs. And there are slightly more sensitive tests that we can send off to the lab if it's appropriate for the farm. So I'd probably suggest speaking to your usual vet about fluke. Fluke is very, very farm specific, and testing will depend on a lot of factors, including what stock you've got, where they're grazing, and time as well. So, but yes, it absolutely can test for fluke too.
Thank you. Thanks.
No problem.
Great stuff. Thank you for the questions. Have we got? I know we've run over a little bit on time. We just got one question in the chat, Emily. If we could make that our last one. It's from from Robbie. We're wondering what anthropomorphic species other than the 3 you mentioned earlier can be found in typical grassland.
Good question. Not really in my area, hugely my area of expertise. So most sort of dealings I've had with it has been in terms of herbal lays and reseeding herbal lays. I think it probably very much varies, depending on where they are, what land's around them, things like that. When we talk about them as herbal lays, we're talking about purposefully seeded pasture. Chicory in particular can be a little bit temperamental about where it'll seed, how it'll grow, and has to be grazed fairly specifically to keep it viable over time. So honest answer, not sure I'm the best person to ask. But the other thing is to have a walk through, have a kick around, see what you can find. There's quite a few good apps out there that you can take a photo of stuff and say, okay, what is this plant, and it'll pull something back up. So it's probably a good way to have a look through your pasture and see what is there already potentially, and have a chat with an agronomist or someone that can give you a little bit more insight if you were looking to plant and to cultivate something with more herbs in.
Great stuff. Thank you very much, Emily, for answering those questions, and thank you also for all the questions from the group. I'm going to stop the recording now. So